Our project was on sustainable energy use in the United States Department of Agriculture. The United States Department of Agriculture consumes a total of around 8.3 trillion BTUs of energy each year, according to 2011 data. In the USDA, natural gas use accounts for 1.7 trillion BTUs, while coal accounts for 0. Petroleum is the largest with 4.6 trillion BTUs. Aviation gasoline consumes 0.1 trillion BTUs. Fuel oil consumes 0.6 trillion BTUs, and jet fuel consumes 0.9 trillion BTUs. Liquefied petroleum, gases, and other types of fuel used in vehicles and equipment, mostly alternative fuels such as methanol and ethanol, utilize 0.4 trillion BTUs, and motor gasoline uses 2.6 trillion. Electricity consumption is approximately 1.8 trillion BTUs. Purchased steam, chilled water, renewable energy, and other fuels consume only 0.2 trillion BTUs.
The first step in creating a sustainable energy future in the USDA is to replace the 4.6 trillion BTU of petroleum with an alternative renewable fuel source, since petroleum accounts for the highest amount of energy consumption. Biofuels would be an example of a renewable fuel source. Out of the 4.6 trillion BTU of petroleum, motor gasoline accounts for 2.6 trillion BTU. Let's say that an average vehicle uses approximately 500 gallons of gas each year. One gallon of gasoline is 114,000 BTU, so each vehicle used by the USDA would use 57 million BTU of petroleum. To find the number of vehicles the USDA uses, take the 2.6 trillion BTU of petroleum that the USDA uses per year and divide it by 57 million BTU of petroleum an average car uses each year. The number would come out to be approximately 45,500 vehicles used by the USDA. If none of these vehicles could run on biofuels such as biodiesel, the USDA would have to replace them. This would be a very expensive operation and likely not feasible.
Jet fuel uses 0.9 trillion BTU of the 4.5 trillion BTU of petroleum used annually by the USDA. Jet fuel has approximately 118,700 BTU per gallon. So if the 0.9 trillion BTU is divided by the 118,700 BTU per gallon, it equals about 7,500,000 gallons of gas used by the planes each year by the USDA. An idea is to replace jet fuel with aviation biofuels to make it more sustainable. Aviation biofuels are practical. An option is mixing second-generation biofuels with existing aviation fuel supplies up to 50%. Renewable jet fuel comes from the feedstocks that green plants produce. This absorbs CO2 and converts it to sugars and oils, which then can be turned into low-carbon jet fuel. The feasibility of this is a lot more likely to replacing 45,500 vehicles.
The United States Department of Agriculture's electricity consumption is 1.8 trillion BTU. There are many possible routes to take if the USDA wanted to collect all of their energy from renewable sources. One option is through wind energy. If the USDA were going to gather all of their electricity from wind energy, they would need to find out how many wind turbines to build. The first step would be seeing how many kilowatt hours an average wind turbine would produce in a year. For example, let's say that the USDA only uses 1.5 megawatt turbines with a 25% capacity factor. To calculate the kilowatt hours produced in a year, multiply 1.5 megawatts by 365 days in a year by 24 hours in a day by the 25% capacity factor. This equals 3,285 megawatt hours, or 3,285,000 kilowatt hours. Then convert the kilowatt hours to BTUs by multiplying by 3,412. This would mean one wind turbine produces 11,200,000,000 BTUs, or 11,200 million BTUs of energy each year. Then divide the total electricity the USDA uses, which is 1.8 trillion BTUs, by 11,200 million BTUs to calculate the number of wind turbines needed. The answer comes out to be around 160 wind turbines. Now the question is, how much land is needed to build 160 1.5 megawatt wind turbines? The 1.5 megawatt turbines are massive, weighing around 164 tons. Two adjacent turbines should have 10 rotor diameters distance clearance in the direction of the wind, and 3 rotor diameters in the other directions. If the USDA built their turbines in a line perpendicular to the wind, the 1.5 megawatt turbines would need at least 32 acres for each turbine. If the USDA wanted to build their array so it could take advantage of the wind from any direction, each turbine would need 82 acres. Multiply 160 turbines by 82 acres per turbine, and the answer is a total of 13,120 acres of land needed. This is equivalent to 20.5 square miles of land. The cost of setting up 160 wind turbines would be between $1 million and $2 million per megawatt of capacity. The total cost would be 1.5 megawatts per turbine multiplied by 1.5 million per megawatt multiplied by 160 turbines. The price comes out to be approximately $360 million. This idea to generate all of the United States Department of Agriculture's electricity with wind turbines seems like a very expensive one.
Another route the United States Department of Agriculture could take would be to supply all of their electricity through solar energy. As stated earlier, the USDA uses 1.8 trillion BTU of energy a year. The first step in finding out how many solar panels would be needed is to decide upon an average size of solar panel and see how much energy is produced from just one of these panels. Typically, a modern solar panel produces between 250 to 270 watts of peak power in controlled conditions. Since solar panels produce direct current and buildings run on alternating current, there are losses when converting the energy from the sun into DC power and turning DC power into AC power. The ratio is called the rate factor and is usually about 0.8, which means 80% of the DC power is converted into AC power. The USDA needs 1.8 trillion BTU, which is around 530 terawatts hour. Divide the number by 365 days in a year to get the USDA's daily average electricity use, which is around 1 terawatt per day. After that, take the kilowatt hour per day and divide by the average amount of hours of sunlight per day, which is roughly 5 hours. This number is around 300 megawatt of AC output needed to cover all of the USDA's electricity usage. The final step is to take the 300 megawatt and divide by 0.8, which is the rate factor. This equals around 400 megawatts. What this means is that the USDA will need 145 of 250 watts solar panels. The cost per watt is around $6 to $8 per watt in many parts of the USA. This price includes parts, labor, permit fees, overhead, and profit. The total cost for all the solar panels the USDA would need is found by multiplying 1,045 solar panels by 250 watts per panel by $7 per watt. This price is around $3 million. The cost of this is a lot lower than building enough wind turbines to produce enough electricity to power the USDA.
One last option to think about for generating 1.8 trillion BTUs of renewable electricity is generating it through hydroelectric power. Hydroelectric is the most used source of renewable energy in the United States. There are two factors to consider when trying to find out how much electricity a hydroelectric plant can make. The first is how far the water falls, and the farther the water falls, the more power it has. The distance that it falls typically depends on the size of the dam. The second factor is the amount of water falling. More water falling through the turbine will produce more power. The formula used to calculate the power of a dam is power equals height of dam times river flow times efficiency divided by 11.8. The 11.8 converts units of feet and seconds into kilowatts. Let's say that an average hydroelectric dam in the United States is 300 feet tall and that the average amount of water flowing in the river is 500 cubic feet per second. The efficiency of the turbine and generator is 80%. To calculate the power, take 300 feet times 500 cubic feet per second times 0.8 divided by 11.8. This equals 11,186 kilowatts. To find out how much electricity it makes in a year, take the 11,186 kilowatts by 24 hours per day by 365 days per year. This equals 97,993,220 kilowatt hours per year. As stated earlier, the USDA uses 530 terawatt hours per year, so the USDA would need around 5 of these hydroelectric power plants to produce all of their electricity. The cost of this operation can be calculated by taking the price per kilowatt, which is around $2,500, and multiply it by 11,186 kilowatts, and then multiply that by 5 power plants. It costs around $140 million to build these 5 hydroelectric power plants.
The United States Department of Agriculture uses about 8.3 million BTU of energy per year. A large majority of this amount is taken up by petroleum use, which is 4.6 trillion BTU, and electricity use, which is 1.8 trillion BTU. These solutions to make the energy used in the USD would be to replace the 0.9 trillion BTU of energy used by jet fuel with biofuels, and also replace the electricity used by using wind, solar, and hydroelectric power. This could be a feasible operation and would reduce the United States' usage of fossil fuels and would contribute to a healthier, more sustainable planet.